Hello, good afternoon again. Thank you for joining us for the Hydrogen and Fuel Cells and Batteries Group Exhibit 2016. My name is Robin, and this afternoon we're talking to Dr. Emory DeCastro, who's the CTO at Advent Technologies, Inc. Thank you so much for joining us. Hi. Good to see you.
Thank you. Thank you for the introduction.
Thank you. So please join us, have a drink on the house, non-alcoholic, but maybe later some alcoholic ones. First of all, the first question I want to ask you is, can you tell us about your company and about your history?
Yes, certainly. So Advent Technologies, they're the leader in what they call high-temperature PEM, high-temperature MEAs. And what makes these special is they operate between 160, 220 degrees C, which gives them certain advantages over what we call low-temperature technology. In fact, in a way, they're sort of the just-right technology, right? Low temperature, you have to worry about water, you have to worry about contaminants in your hydrogen. Very high temperature, like solid oxide, is too hot. In other words, you need exotic materials and ceramics. But if you had an MEA that operated 160 to 200, you could use plastics, and it still has all the advantages of the heat. So it's sort of the perfect product.
Okay, fantastic.
Yeah.
And I heard something about your licensing BASF technology. If you can tell us about that.
That's a good question, because in reality, our company has two types of MEAs, what we call two platforms. One is TPS, based on a pyridine membrane, operates probably the hottest of the two. In some forms can even go up to 220. And then the other is called PBI, which people know very well. And that's the technology we licensed from BASF. It was one of the early technologies. It's a very high power technology, operates at 160, and we use both electrode technology and MEA technology licensed from BASF.
Thank you. What are the applications that we can use your product for?
It's a wide range. Once systems are simplified because of the heat, there's many things you can do. So, for example, one customer called Ultracell, they make a 55-watt battery range extender. You start with methanol, you reform that. It allows people to take a lot less batteries on their missions. But there are things like micro CHP, where in your home you can get both hot water and electricity in what they call a distributed way, which is very exciting.
And how does that, if you can expand a little bit on that, on how that works?
Yeah, certainly. So it starts with natural gas, which is plentiful. There's a natural gas grid. There's a part called the reformer, takes that apart, the hydrogen, goes into our system, which then produces both hot water and electricity from that. Yeah.
Thank you very much. Yeah. Do you have any R&D projects that are on the market at the moment?
Oh, yeah. In fact, we're always trying to show new applications of our technology. One very interesting one, it's called IRMFC. It's sort of a complicated thing, but actually it's just a project name. But because with some of our membranes you can operate up to 220 degrees C, you're actually able to build in methanol reforming catalysts within the stack. I know it may sound complex, but actually it's making things a lot more simpler, where now you have one box where methanol goes in, it gets torn apart to hydrogen, goes into our high temperature MEA, and then electricity and heat come out. So that's a very exciting new application that we're working on. The other one is more fundamental and basic, but very important to our customers, called DEMStack. Here it's really looking at the basic mechanisms of why things fail. Why do things fall apart? And so with that knowledge, we then try to find out why they fail and then make our components better so they last longer.
Sorry, the acronym that you mentioned before for your R&D project, what does it stand for?
Yes, so DEMStack is for degradation and mechanisms for stacks, and the IR is internal reforming of methanol fuel cells. You had to ask that one, right? That was a tough one.
Thank you. Not a technical background, but now I know. Thank you very much. And so your topic being a hydrogen purification with high temperature PEM, can you speak to that?
Yes, this is a very exciting new area for us, a new application. if we think about how humanity actually got their energy and got their fuel, it started with wood, right? We had wood, then we moved to coal, a little bit higher energy density, then to oil, great discovery, turn of the century. Now many people believe we're in the natural gas phase. And in the end, of course, as we see all around us, the final step will be hydrogen. We all know this is our progression through energy. But the key part about all these transitions is they don't end at once. We actually still use coal for energy. We use wood in our fireplaces. It's more of a luxury today, but we still use those technologies. And so what we believe is this new application of our product is acting as a nice bridge of going from the natural gas age to the hydrogen age. And it works in a great way. So now I'm going to get technical on you for a little bit and change things around.
Please do.
So this is how the bridge works. Is you would take a fuel cell style MEA, but instead of generating power, you actually apply power to it. You make it in electrolysis mode. You would feed that what we call reformed hydrogen, say methane that gets split apart. You feed that to the anode. You only oxidize the hydrogen. It goes through our high temperature membrane to the cathode side. You reduce that, and it becomes pure hydrogen. So in a way, we have a very simple and effective way to clean up hydrogen. And it's a hydrogen purifier and concentrator as well.
Thank you. See, that wasn't too technical.
Yeah, yeah.
And so that is what. That is how your product is used to purify hydrogen. Then.
Yes, that's
Indeed.
right.
Okay.
Yeah.
In your opinion, how does your technology differ, or let's say make it better than other technologies out there?
Yeah. Well. Today, if you follow the hydrogen world, for hydrogen purification, there's well-known technologies. One is cryogenic, these huge plants that literally freeze gases into solids and distill off. This is probably the lowest cost way to make hydrogen, but you can only make it large scale, so you have to bottle it, put it on a truck, and that's very expensive, right? So it's not the best, and it's very hard to make small. There's what they call PSA, pressure swing absorption. That's by far the most common method. But you have to start with relatively high concentrations of methane, and you have to tune the beds of these devices to the specific fuel that you have, so it's not very flexible. There's a relatively new technology called palladium separation membranes. They can be made small, but again, you cannot concentrate the hydrogen. If you have certain impurities like sulfides or ethylene compounds, the palladium membrane doesn't work as well. And so this electrochemical separator solves all those problems, and it can concentrate dilute hydrogen and purify it, which leads to very exciting applications.
Thank you. I like how you tell the story as well. What challenges does advanced technology face, if any?
Well, and actually, an interesting challenge is sort of the applications of how to use this and how to design it. But I'll go back to an interesting application, because I had said before you can concentrate. And when you look at, say, all the potential hydrogen generating capacity we have, say taking wind energy, electrolyzing water, making hydrogen, how do you store that? How do you transport that around to all the homes? There's been an interesting concept, and I think it actually originated here in Europe, where why don't we use the natural gas grid as a way to store and distribute hydrogen to your home? Because many, especially in the cities, have natural gas grid. And that is a great idea, except there's one limiting technology. How do you get the hydrogen out of dilute hydrogen in natural gas? And this is where our technology is perfect. We can take anywhere under 10% hydrogen, 5% hydrogen in natural gas, go through our product, and produce purified hydrogen that's concentrated at the other end. So it's a great solution to that. But there are challenges. So not to forget your question, there are challenges. And one of the challenges certainly is designing this MEA for the job of hydrogen purification. Today, we actually sell our standard fuel cell MEA into this market. We actually have several customers and a lot of different ranges, from either startup companies to established companies that use our product today, but we're actually selling a fuel cell MEA, not one designed for this. So the challenge is, can we change the design of that to decrease the cost? And I think we can. We're sort of on that path.
Is there anything else that you'd like to add in that area?
Certainly, I think there's a nice example of where it is actually making an impact today. There's a company, Fuel Cell Energy. They actually have a booth here, And their specialization is large-scale molten carbonate fuel cells. They're typically megawatt plants. They run off of natural gas. It's internally reformed. And their main product today is heat and power, and they do a great job with that. But what they have found is they could actually take these high-temperature MEAs in electrochemical hydrogen separation mode, and they put another stack on the tailpipe of their anode. So instead of losing unreacted hydrogen out to the atmosphere, they can actually separate it and create a third product for their device. So now they create power, they create heat, now create pure hydrogen, all from methane coming in. It's a nice example. They've worked up to 25 kilograms per day just for a pilot scale to show it works. And they actually use that hydrogen in their manufacturing plant. So it's beautiful, right? For their own devices, they use what they clean up. So.
Thank you. What is there like a main market that you have? Is it more North America, more Europe, or all around?
Yeah. For this hydrogen separation, our main market today is in Europe. It seems Europe is adopting, but there are some startup companies, United States, that are moving and trying to do that. In general, with regards to advanced products or fuel cell products, we actually sell all around the world. But Europe is a great market for us. They're adapting it.
Of course, they're advanced.
Yeah.
Absolutely. And as far as other products that you're creating, anything in R&D as well that you want to mention?
So on the R&D side, I mentioned those two research projects, but the one thing we're actually working a lot on behind the scenes is cost and getting the cost of our components down. Whether that be from new catalysts, lower precious metal loading, new materials that go into the MEA to reduce the cost of the MEA, or even assembly, coming up with better ways of assembly at lower cost, higher yield, which is always the issue. So.
And so cost, that's, do you think, the main issue at the moment, like to lowering the cost? Or what's one of the problems with that?
It really is. And I think it's probably an issue for all of us. So that is that the higher cost product can only target the higher value of what there is. I was taught a very general equation of what makes a simple business, right? And so the value as perceived by the customer, it has to be greater than the price, because you won't buy it unless you think it's a value, and the price has to be greater than the cost, right? And we're working on all three of those things. The high temperature has very good value, and so I believe it is worth the cost, but we're trying to reduce the cost of that as well.
And as well, having a good quality, your product being high quality, which is the case in your company's case. And on the flip side, we've spoken about the challenges. Some success stories that you can share with us, some recent ones or own projects and awards.
Yeah. Well, I do like to always go back to the portable fuel cell one, the small 55 watt, largely because they were an early customer. And it really illustrates sort of the rise and fall in fuel cells and what happens to all of us. So they started out as one of the first customers we ever had. They grew, they showed proof of principle. But then, like what always happens, it took longer for customers to qualify a device. They went through difficult times. But then a strategic partner purchased them. It actually is a very specialized military battery company, so they knew the market. They knew the technology was really applicable to what they were doing. And so now with that safety behind them, they're continuing to grow and to expand throughout the market. So that's been a great example. Another example is on larger systems. Here, this has to do with power backup for telecom. Certainly, the low temperature hydrogen market has done very well, showing that for telecom backup, it's a very good match. However, one of the issues is the hydrogen. And you either have to store many tanks of hydrogen or have difficult hydrogen logistics getting hydrogen to remote sites. Because our technology runs hot and is well matched to reformed hydrogen coming from reformers, a lot of our customers use methanol as a fuel, which has high density. So you have a big drum of methanol, high temperature stack, and now the telecom customer can run these in very remote locations and not have to worry about the hydrogen logistics. That's another great success story.
That's a really great success story. Are there any questions at the moment? Oh, please, 1 second, please. Excuse me.
Hi, Don Drake. I was just curious to know what's for like telecom backup or backup power applications, since it's a higher temperature, what's the startup time, the response time once power goes down?
Yes, and that's a great question. In fact, that's probably the strength of low temperature and what some perceive to be the weakness of the high temperature. And the smaller 55 watt unit, which doesn't answer your question, but there's the shortest I've heard, 15 minutes, but they get there by having a hybrid battery on board. So what the telecom operators do is that it is always a hybridized system. And so there is enough battery backup to last for this 20 to 30 minute startup cycle. Some other telecom backups, what I call cheat, where they preheat the system so it's in a slightly heated mode, and then they can get the higher temperature very quickly. Yeah.
Perfect, thank you. If someone was too shy to ask any other questions here now, you can please come visit Dr. DeCastro in booth C38/2. And again, this is Advent Technology, and Dr. DeCastro is the CTO at that company.
Yeah.
Thank you very much for joining us today.
Thank you very much.
I think it's really nice. Thank you.
Bye.
Perfect. So up next, we have Saba Suri of Mahitech Saral joining us, and the topic will be hydrogen storage solutions, compressed and hydrates tanks. And that talk is coming up right now. Thank you.